Yeah, привет. Hello and welcome to testing in the modular world. Who's been testing? No hands up. Everybody. Who's been trying out the Java module system already? Java 9, somebody? One. Just playing around with it? Or in production? But, okay. I will say first who I am. Christian, you already heard it. I'm working for a company in Germany called Micromata. I'm a JUnit 5 core team member since 2 years and active Maven committer since 2 weeks to get the new JUnit 5 into work into other tools. So if you want to contact me on Twitter or on my blog, you're welcome. So let's start living in the material world. Wrong slide. Testing in the modular world. And I will tell you what I'm doing here, and I hope you see much clearer after testing in the modular world, because it's new. It's very new, and what I'm gonna show and present to you is how you can do it, and not how you should do it, or it's not baked in stone yet. So it's experimental. We have working happy paths, but maybe in 2 years, everything I will say now will be superseded. So it's about JUnit 5, how to launch tests, the talks about writing tests with JUnit 5. Mark already did here at Heisenbug last year and the year before. We're gonna introduce ourselves to the Java modules, very lightweight, just what we need to write tests in modules. And we're going to use foundation tools like Java-C, jar, and Java, because those tools are really up to date, and you can use them and nothing will break. IDE support, IDEA, Eclipse, whatever, is not really there yet for both my topics, JUnit 5 and modules. So, what is JUnit 5? There is no JUnit 5. It's just a word. And we didn't change the brand. There is no JUnit 5 in the sense of a single artifact. You can't declare it, just JUnit in your dependency management tools and flip from 4 to 5 and then you're done. This is not going to work because JUnit 5 actually looks like this. Here you see the big picture, and as you can see in the colors on it, JUnit 5 is the gray box around 3 parts. And why the heck did we do this? Re-implement the whole library, which is known to virtually everybody on the Java world, because when rewriting or looking what other frameworks did, and we want to write JUnit 5, we saw something is not working when we evolve a library like JUnit 4, because everybody is depending on it and assuming things, even in the inner parts, we can't touch it. We couldn't touch it and achieve what we want to achieve. So, what are the customers of a testing framework? There are basically 2. One, everybody who's writing tests, you know, test annotation and you write your methods. And there are the tools on the other side that launch and know how to find your tests and create reports and whatever is in the middle of it. And another user group is maybe extension authors who makes writing tests easier, but they are in the first group actually because that's how about writing tests. So let's dive into the red box, the platform. It's one below, and it's the main tool or the main interface towards the IDEs and the build tools. So JUnit 5 is composed of the platform, which is the foundation for launching test engines. It defines mainly a test engine interface. 2 methods in it, one to discover test, one to execute tests. That's it. On the other side of the platform, from top, there are test engines. Now we dive into the green box, Jupyter. So JUnit 5 is a platform as a basis and with a default test engine implementation. Jupyter is a test engine. Why it's called Jupyter? Starts with JU, like JUnit, and if you count from the sun, Mercury, Jupiter, the 5th planet, yay, we got our name. And I guess you know the name when we invent JUnit 6, it will be called Saturn. Okay. Here is the new programming model, the annotations, the interfaces you need for writing tests in the new world of JUnit 5, mainly, and you know it now, and you always will say Jupyter for it. Also, the extension authors will use this package, and it's okay to say this is JUnit 5 if you have the straight line from JUnit 4 to 5. So Jupyter is, the street name is JUnit 5. So now to the yellow box, vintage, legacy. Yeah, it's a test engine. It runs on the platform, and vintage knows how to execute JUnit 3 in 4 tests. So why did we do this? Because of fun? No, because when you have a large set of tests that are running and want to migrate, you just plug in a test engine, like this one, on the platform, and all your old tests will run. So just easy as it can be. You have your work already done, and we support it by default. So that's JUnit 5. But it doesn't stop there. There was a blue test engine, and now I remember from yesterday night, we had a talk about how to implement your own test framework. Maybe you want to skip the part and integrate with the tools. So here's your chance to implement your own test engine. You define what a test is, what it looks like, what it needs to run, like text files, like CSV files, like streams from whatever, and you know how to evaluate a test. That's all a test engine is about. Okay, and many third-party engines are already available, like Spexy, Spec, Kotlin Test, Cucumber, Drools from the Apache. JQuick is a property-based testing engine. So roll your own, have your ideas, what a test should be, implement this interface, and you get tooling support for granted. There's a wiki page, third-party extensions we can look up. So actually, this is JUnit 5. These are the modules. If you open all the boxes, and on top left, you see the old single artifact, what JUnit 4 was, and all other artifacts are needed now. So let's dive into the platform launcher inside the red box. This is how we feed test engines with the assets, what to look for, and you can build a request builder and then say, I want to execute all tests in a package. We are on the GVM, so package is a common asset there. You can say have a single class or select a module. You can have like, here's a directory, here is whatever you can think of common sources. Then you can apply filters to it, like only class names that end with tests. So discovery may be sped up with it. Then you have your launcher factory, and you pull in the request, you just build it, and there you go. There's the test run. And you see, there was a single JUnit 4 test. There are a couple of JUnit 5 Jupyter tests, and they're all executed. Okay, what does a Jupyter test look like? First, you need to import the new API, new package name. You can have a test class and use package private modifiers now, no more public, if you want to save some typing. Still, it's called test. It's no better name for it yet invented, but it's okay. And you can have assertions like you do, so nothing magic in here. Some magic is when you want to have categories or groups of tests and want to attach something to a test class or a test method. You can have it with a new tag annotation. And you can combine them in a third-party annotation, combine another annotation, and use it on your test class. So it's a basic inheritance of annotation frameworks. So you don't have to repeat yourself on the test methods when you have a set of categories, and you can combine it in this one. So Jupyter has a lot of features. We just skim the surface of it. You have play names with emotion support. We have tagging and filtering. We have a set of basic assertions, no longer Helmcrest, just totally new written one, but very basic. So use third-party assertion frameworks when you can assert shades, for example. Assumptions, you can disable tests. You can conditionally execute or disable tests before they are executed in the discovery phase. We have more features in Jupyter. That's all not part of the talk. Just want to demonstrate the content of the user guide. So here is the link. Follow it and learn about Jupyter and the platform. And of course, third-party extensions exist already. There are many. Spring is fully supported, Mockito is supported, Docker is, Wiremark, JPA, Selenium. We had a talk about this earlier. You just have a class extension, extend with, and you're ready to inject a WebDriver wherever it comes from. But the cool thing is extensions. You can have many extensions in the test class now. There's no test runner which defines your test flow. You just have the standard flow and import and extend your test class with whatever you need. So, Java platform module system. It will really touch the surface here again, but enough to bring the two words together. It was developed a very long time under the name Jigsaw, introduced in Java 9, which is already end of its life cycle. So don't use 9, use 10. Up until September, then use 11, because 10 is not longer supported. And what were the goals of the, JPMS, I should not call it like this. Mark Reinhold said it sounds like a disease or a very bad condition in the health system. So it's Java module system. Reliable configuration is one of the goals of the Java module system. At compile and runtime, you want to know your components and want to fix it. And that's one of the reliable goals, is reliable configuration. You want strong encapsulation. Your components want to hide something from the outside so that you can change implementation at a point and nothing breaks. You just want to have a known surface of your component. And with this, all things get better, integrity increases, and also performance will get better when you have those things in place. So what is a module? According to Jigsaw, it's a long thing. We make it shorter. For us, it's just a named program component, which contains a set of packages and some metadata. The first, it's basically a jar file with a descriptor where you say this is for me internally and this is what's for others. And you define also what other modules you need. And with this, you have a graph. You can build up a graph and say if this configuration will work. So let's look at an example of such a module descriptor. It's a standard compilation unit, like any Java class, and you can compile this module info.java file into a .class file. And here you have the keyword module. It's new in Java 9, and it defines the name, like example foo. Here you see the requirements or the read lines of the module. It's referring to module names, other module names. Here it says which packages are exported out of the jar file, so which packages are usable to the outside. The first one is general usable from everybody, from every other module. The second one is a directed or a named export, so you can control who uses this internal package. Maybe one of your own modules needs it. And you can open at runtime to other frameworks or other modules in this case. And we will get to this later. This means you may reflect into the parts here. And there's a service consumption and provision part of it, which replaces the meta-inf /service directory and files you may know from the Java util service loader interface, which was introduced in Java 6. So we need something to test, so let's write a modular project. Just have an application, a module named example application. It only contains one single class, namely main. It's our entry point. Does nothing. I don't show the code because it's really a one-liner. But more interesting, it uses a library we develop at the same time. It's under our control. It's called example tool, which publishes a calculator type to everybody who wants to use our tool, and has an internal math helper to do the calculation work. But we don't want to expose that, but we want to test it later, if the math is right. And as a bonus, I'll implement a test engine, an ice cream machine, because in St. Petersburg, the weather is so sunny. It's amazing. Everybody said here it's always raining, but not for me. Okay, so let us look at the source. Like I said, very simple. Have a package structure, have your main class in the example application directory, and in the root of it, we have our module descriptor. Same goes for the tool, calculator, and an internal math helper. And the ice cream machine, yeah, there's a flavor, here's scoops, and the machine is the one that implements the test engine. So let's look into the descriptors. In the first block, you see our two modules. For our example application, on the right, it requires the module tool. On the left, you see the tool application, which exports and package. So nothing fancy here, just basic modular setup. The test engine implementation module is called ice cream. It requires a module, namely the JUnit platform engine, and provides a test engine by or with the ice cream machine class. And that's all you need to register a test engine into the JUnit platform. If they are on the module path at the same time, this engine will start to work when the platform launches. So let's compile our source, main source still. Yeah, Java C, we just saw it. Have a destination directory, bin main. tell the compiler where all the source modules or the source of the modules are located, and name each one because we want to have them separated in the destination directory. Same goes for the ice cream module. Don't have a slide for that. And then we want to package our binaries. Use the foundation jar tool here in creation mode. Name and specify the target file. Com example application jar. It's just a standard jar for now. Specify the main class. So if you run the module, you don't have to repeat this, what we already know. Switch into our just created main directory and compile everything into a jar file. And when we look at it on our disk, you see every .java turned into .class. No magic here. Just the same structure for all the modules. And here we see the three modular jars because they are providing a module descriptor in the root of it. Okay, now we have a application. Before we test it, let's look briefly into what is generated into the modular files. We see its name in the first com example tool, in the first place. And now the jar command can describe the module more. It sees a module info class, which is the descriptor. It says, yeah, I export a package for everyone. I require Java base, which is mandated. You don't have to name it. Java base is always in, so no need to name it, but it is reported here. And it contains a package com example tool internal, which is not published, just inside the jar. Yeah, application, almost the same. First the name, then it requires Java base, we already know this, and our example tool. It contains the com example application package with our main class, but it's not exported. The Java runtime knows how to poke into your modular jar and instantiate a class. And of course, yeah, here we go. Now the module name is enough. If you want to launch it, you can have this inside here. So the last one was the ice cream module. You see you can have versions in here when jarring the modular jars. It requires Java base. That's not a surprise. But here we see it requires org.jn platform engine on the module path with all its dependencies to run. And it tells the service loader mechanism, yeah, we have a platform engine, test engine implementation with our class we have here, which also must not be, or may not be published. It may, you can publish it, but it doesn't hurt if you have not exported that package your implementation lives in. Okay, so far so good. We have an application. Now, testing in the modular world. Does any one of you remember, like 15 or 20 years ago, when we wrote tests for the first time without the support of a testing framework, how that looked like? Basically, it was, you had your main class in a package, and you had some test class runner main thing next to it. And they were cluttered with all the test codes, and all supported a main method. And you executed them one by one or in a batch process. And if there was no execution thrown or exception thrown, yeah, your tests were green. And time passes by, and you replaced it with a test framework. You know, your annotated method with a test, or you know, you named it test. The method had to start with test, and then it was found. Later came the annotations. And there was a split, which was good, because in the first time you had to, when you want to ship a product, you had to strip away all the test artifacts, all the test classes, all the test dependencies. You don't want to deliver that. So you have to separate it on the disk before, and then it's easier to compile your product. But why did it work? It works because of the class path. The class path is just a repository which tries to find the resource you want to use. So if you add another entry to the class path, like main and test, it will find both. If you have some class in this package too, and have this root as a first entry or before the main entry in the class path, this one will never get used. And this is a part of the hell of the class path. It tries all the time to find resources you need, and will never stop doing so until it's in the end, and the first hit is served to you and to your, what you want to achieve here. But the module system has some rules. And one of the rules is you can't have two modules with the same name on it. Module name must be unique. So if you look here, you have com xyz, and here black box, and here com yz. Oh, this will fail, because that's not unique. If in the black box module we had a package called com xyz, it will fail again, because a package name has to be unique too. So you can't inject another package into another module, or the same package, and have it split somewhere. So it's a split package failure. So how to escape from this? And we want to write tests like we always did. We want to test the surface of the module. I call them black box test modules, so we only see the exported parts of it. And we want white box testing, where we can see and test our package private components. Here we go. Write some tests like in a black box. Use different APIs, Jupyter, JUnit 4, or a property-based engine like JQuick, doesn't matter. And have a module info, because we need some other modules at test time. Same for the application. This is now a white box test. We are using the same name and the same package like we always did, but it's not going to work with the module path. Keep that in mind. Calculator and the tool module the same, and ice cream just as is. So let's look at the black box module descriptor, the test module descriptor. Actually, a better name would be module test Java, but the compiler does not support that. What I did here was copy all of the main requirements and directives into the test module descriptor, added a keyword named open to it, and added our requirements for testing. Here be Selenium, a search, whatever you need. And this makes the black box testing module work from the module part of side. Okay, I always talked about that. Okay, for the tool module, just the same in white. We open our module, we export our package like we did in the main module descriptor, and we require some API for testing. Now, 3 solutions are here to help with blending in your test code from modules into the main modules. First is, don't use model path, just use class path. Second is, when executing the test runtime, I merge in the test binaries. And the third will be, I will patch the compile time of the test. So let's do the first thing. We just avoid the module path and do everything on the class path again. Because Java 9 introduced the model path, but the class path will not go away. Everything will work like it did before 9, except for the unsafe parts. But common use cases mostly just work after you reinstall a new version of the JDK. So how does it look like? We have a compiler. We're going to use it, have a destination directory. We put our modular jars on the class path. All module descriptor information will be discarded and ignored. Just packages, just simple plain jars with an extra entry. We put all our dependencies. We have it locally in the lib folder here in the class path. And now the test source files at the end, and hope everything goes good. And now we've compiled it all to class files. And okay, after compiling, we want to launch our tests. That's the second step. So we set up a class path again. It looks different now because we have compiled something. We need to name the main class. It's the client of the platform here, the console launcher. It needs some options where to put the reports to, and it should scan the class path for tests. Okay, now we have a report on the console, and we see a snippet of it. We see 3 test engines we're executing, and it looks very good. And the parts I left out, there are only parsing tests, but one single test did fail. It has assertion, or assumption in this case, that it lives on the module path. And you may, at runtime, use the module path for information gathering things, and all those APIs introduced in Java 9 will report differently when you're running on the module path or on the class path. So it's another factor to consider when you're writing a library and testing in the library. Are you on the class path? Or are you on the module path? And this will change the outcome. So if you see something like this in the next years, think about it. Where is the jar at? And this may influence the result of a test. So the assumption was we are in named module, we are not, so the test failed. Yeah, here we see it. Now to the real stuff, the module path. Patching test binaries into the main modules at test time. Yeah, compiling I will left out. It's similar to what we just saw. Now the screen is blank. Here we go again. But we drop the binaries into different dedicated directories, like this one. No, like not this one. And then we're gonna rebuild our module path for the runtime. So we have our main jars, we have our external libraries, and we're gonna do this now. We patch. I'm not doing anything. The screensaver? No. Everything is online. Just the projector. Okay. So patch module means that whenever the module system sees a module, we can add a different source of class files at runtime. So whenever the compiler sees the example tool, it should look also in this directory for sources of this module. So we enhance the content of the module in this with this directive. Oh, no, the focus is on the wrong. Here we go. You remember the small open keyword? We have to add this too, because otherwise no testing framework may reflect into your modules to find test classes. So you have to add open to every module we want to test. This black screen is magic. I have to go faster, huh? Okay, and of course we have dependencies in our module descriptor. We have to add them at the command line too, and I think that's not really a thing we're gonna use a very long time, but that's the way it should work according to the Jigsaw team. So I propose a third solution. We stay on the module path as close as possible to the real world, but let's patch the main sources into the test modules at test compile time. So when we compile tests, we just need our external libraries on the module path. We need to patch now the main sources when we compile the example application test module. So on the left side, the test module, and on the right side, there are the main sources. What we do here is we invert the situation. We now say our test module is key, and our system under test or classes under test are a necessity we have to have for compiling. But now we can just add the source path for our own modules, append all Java classes to it, and compile happily. And then, at runtime, it really looks like almost on the class path, where you add some default modules. Here's all the modules we have, including our main and test modules, merged into one, the external libraries. Now we resolve all modules on startup. We say this is our main module with the main entry point we want to start. Give it some options like we did before, and here you go. We have test run, and all engines were executed, including our ice cream engine, which this time produced stracciatella, chocolate, vanilla stracciatella. And the key point is now the test which uses the module system inside the assumptions now passes. So, takeaway for this technical talk is there is no JUnit 5, use it. Especially Jupyter, and if you have an idea for an own testing framework, the platform may be this what you're looking for, and you get tooling support for granted. Try and test the Java module system. It's not going away. We will have to face it someday, sooner or later. But how tests are executed on the module system, it's still on debate and to be seen. So thank you for listening. I hope you see a little bit more clearer now. Yeah, that's it.
Thank you very much. Do you have any questions for Christian? Okay, so if you have, okay.
So thank you for the topic. I'm not pretty familiar with the Java modules, but can you clarify the main advantages of modules over build systems, build tools like Maven and Gradle, because I can inject the class path in Maven configurations and so on. So
They're two different things, apples and cars. A build tool, you specify what you need for the build. But in the Java module system, you declare the parts. It's more like the package structure, more like interfaces and implementations. And the module system is just another thing you can use to structure your application. And if you use it, you get benefits from it. If you don't use it, you don't get the benefits, but everything works. Maven, Gradle, Ant, whatever build tool you use, just works before, works after it, and have to adopt some things. But the module system is just part of Java now. So it's not related to any build tool. The build tool will learn or provide ways to support you as a developer, but that's two different things. Yeah.
Yes, thank you also for the topic. I have a short question.
Yeah.
How many lines should I write to start the module test?
How many?
Lines of code should I write to start this module test? As I have seen that on a screen, there are too many, right?
This is something the build tools will do for you. The best word or best line you may write is 0, no line. So it's just a change in the mindset. So you will write the module descriptors, and the build tools will one day just scan it, look for your configuration, and execute the tests. But this is the future. It's not set in stone yet. So if you have ideas how to do it, tell us. Yeah.
Do you have more questions? Okay, Christian, thank you very much.